Welcome to this introductory tutorial for Eonfusion. This tutorial will provide you with a basic overview of Eonfusion's Dataflow functionality. This tutorial will provide you with an understanding of how to build data flows and how to use Dataflow views. It assumes that you've already seen the overview tutorial. The Dataflow view is the docked window in the lower half of the screen. This view is a workspace for building data flows, which are flowchart-like structures that allow you to access and manipulate your data. This view is called the Getting Started Dataflows view. The main Dataflow view shown here is a special view. It is a parent view from which you can directly or indirectly access any of the other Dataflow views that you create. If we close the Getting Started Dataflows window here, you can reopen it from the main Dataflow. The main Dataflow view is always available from the Eonfusion Org menu. You can navigate in these windows using the mouse wheel. Roll the wheel away from you to zoom out, or toward you to bring the objects closer. By holding down the middle mouse wheel and moving the mouse, you can also move around the view. There is also a zoom to extents option that will zoom the view to the extents required to see all the objects in the window. Data flows are created by linking a sequence of objects together. Dataflow objects connect to your data and manipulate it according to the properties of the objects. Here we can see two data flows within this view. Objects in the data flows are grouped by colour into the different types. The blue objects are data sources, the green objects are operators, and the orange objects are views. There are also data writer objects, which are purple. Looking at the context menu for this view, we can see these groups in the options for adding new objects. The first group lists the data source options, which provide you with access to your data. The second group lists the data writers. The third group lists the operators, which allow you to partition, combine, filter or transform your data. And the last group are the data view options. These allow you to visualize and inspect your data in various ways. We will now look at how to build data flows by adding and connecting Dataflow objects. We will begin by adding a shapefile data source to read shapefile data. Objects are configured by changing the settings on their properties windows. These are accessed via the Objects context menu. The object name property is the label displayed on the object. The path and file name of the shapefile data is entered into the file name property. We need to click OK to apply these changes. Note that the object is now called bathymetry shapefile. We can verify that the data has been loaded correctly by looking at the output data structure view for this object. This can also be displayed from the Objects context menu. We can see that the data has been read in as 3 attributes in the vertices group, X, Y and Z, and 2 attributes in the 0D points group, ID and depth. We can quickly check the data by displaying a table, which is a context menu option when you point to the heading of an attribute group in this view. We can see that we have valid data for X, Y and Z. We will now add an operator to the data flow to triangulate the point data to create a 2D surface. From the operator group, we will select the Triangulate Vertices operator. The ghosted appearance tells us there's no data connected to this object. Objects are connected by pipes. We add a pipe by pointing to the output socket on the data source and dragging a pipe to the input socket of the operator. We will now configure the triangulate vertices operator. The default double-click action on most objects will display their properties. The dataset name in the first group is an optional field which allows you to name the dataset produced by the object. Dataset names are automatically propagated along the data flow. Naming datasets helps to reduce confusion when you're working with a number of different datasets in one data flow. The operator named group of properties, in this case triangulate vertices, are the settings specific to the object. The vector set group property identifies a group of attributes that we can select specific attributes from to connect points to create the surface. This is a common property and it is often automatically set, as in this case. To select the triangulation attributes, you can use the Browse button to display a data structure selector. In this window, the white highlighted areas are the attributes which are available for selection. In this case, to create the 2D surface, we'll use the X and Y vertex attributes. We click OK to apply these settings. We can use the data structure view to see the effect of the triangulation operator. We can see that there is now a 2D surface group within the vector set. Comparing this to the output from the bathymetry shapefile data source, we can see that there was only a 0D point group prior to the triangulation operator. The triangulation has created the surface and added it to the data set. An important feature of Eonfusion is that these workspaces do not need to be saved explicitly. Any changes that you make are saved automatically, and when you close and reopen Eonfusion, the workspace will be restored to where you left off. A useful feature in Dataflow construction is the ability to copy and paste Dataflow objects. Objects can be selected by either dragging a rectangle to enclose them, or by holding Control and clicking on objects. The new objects are independent of the objects from which they were copied. You can delete objects from within a data flow and reconnect the remaining objects, or you can insert new objects. To insert an object, first select and delete the pipe using the Delete key or context menu option. Then create the new operator and connect it in. We will insert a filter spatial feature operator as an example. You may have noticed the coloured halos surrounding the objects. These are used to indicate the processing states. In this case, we can see that the bathymetry shapefile has a green halo. Green indicates that the data has been loaded successfully. You can see that the other objects don't have halos. This is because data has not been requested by these objects yet. Objects can be created, connected and configured without causing data to flow. Data flows when it is required to be displayed or written in some way. We can place demand on the data when we display it in an output data structure view. A red halo now surrounds the filter spatial features operator, indicating that this operator is in an error state. The error message is displayed in the object's tooltip when you hover over the object. The object's events window also has error message information. This window can be displayed for any object from the context menu. This window shows a chronological log of the processing events and includes progress information and error messages. In this case, we can see the error message indicating that a property should not be blank. We need to open the properties window for this operator and set the properties. We set the vector set property and set it to filter using a depth attribute. And we apply these changes. We can see that the error has disappeared, and we can also see that the data structure for the output from the triangulate vertices object has been updated. You may have noticed that the halo was briefly yellow, then blue before it went green. The yellow halo indicates that the object has requested data and is waiting for it to arrive, and the blue halo indicates that data has arrived and is being processed. We can look at the effect of the filter spatial features operator by viewing a table of the data. If we look at the data for the features, we discover there is no data values. To understand what's happened, we should look at the input data to this operator. If we look at the output from the bathymetry shapefile, we can see that the data values for the depth attribute are negative. The filter settings were based on positive depth values. We need to go back to the properties for the operator and change the filter settings. Just moving the table to the side so we can see the results as they change. On the properties, we change the filter to be negative values and apply those changes, and we see that our data is updated and filtered by those minimum and maximum values appropriately. You can insert scene views in your data flows to visualize your data. Select Scene from the View menu. On the scene properties, I'm going to specify the projection that the scene will be displayed in. Applying the projection. The scene view can be opened from the context menu or by double-clicking on the object. You will need to add visualizers to the data objects in the scene to view your data. The visualizers each have properties which allow you to configure how they are displayed in the scene. The scene properties can also be accessed by clicking on the background of the scene display area. I'm adjusting the vertical exaggeration property to verify that the data is three-dimensional. Selected groups of Dataflow objects or whole data flows can be exported to disk for sharing or transport to other systems. This is done by selecting the group of objects and using the context menu export option. Specify a file location and name. Data flows are stored as XML files. Data flows can then be re-imported using the Dataflow import option from the same menu. Importing the Dataflow we just exported gives us a copy of this Dataflow. Using the export option from the background menu will export all the Dataflow objects in the view. You can also export these same objects by exporting the object that represents this view in the main Dataflow window. Exporting a Dataflow view will export all the data flows that it contains. Selecting Export on the background of the main Dataflow window will export all the data flows in the application. Importing and exporting data flows is a useful way of sharing your work. Lastly, a few comments on how Eonfusion stores your data. I have already mentioned that data flows only on demand when a downstream object requests it. When data is provided to an object, the object keeps a copy of it in a cache to avoid regenerating the data unnecessarily. The cache is invalidated automatically if properties are changed that affect the data. When it is invalidated, all the data cached downstream is also invalidated. You can, however, manually invalidate cached data using the Invalidate menu option. We hope that this tutorial has been a useful introduction to data flows. Please take the time to view our other video tutorials to help you get started with Eonfusion. Thank you.